The tides, the water level in the ocean with its up and down movements, were thought to be caused by the gravitational pull of the moon and the sun. But that's not entirely true. It is correct that they were created by the gravitational fields of the two. As said before, in order for a body to be able to rotate in another's gravitational field, it must first overcome it. Conversely, this means that the rotational movement of one body is slowed down by the gravitational field of another. This deceleration only occurs when the moving mass particle intersects the gravitational field line of the Sun, for example at point C. If the direction of movement of a mass particle is parallel to the gravitational line of the Sun, this particle is not decelerated, as for example when the water mass moves at point A is located. When the water at the surface is at point C, this braking propels it in the opposite direction of rotation. When the water reaches point A*, it runs back again. This creates the back and forth movement of the water. Also at point C*, which is beyond point C, has about the same braking effect. Therefore, there is also the same phenomenon of tides there. Earth has a rotational force AU equal to the primal acceleration of the solar system. If we consider that the rotation of the Earth, to simplify, was caused solely by this, the water on the Earth's surface also has this motive force. The effective braking force of the Sun's gravitational field at any point B with an angle theta is equal to In order for the water movement to be driven in the opposite direction, an effective acceleration g theta is required that is greater than the water motive force AU. Then the movement of the water is impeded and it accelerates clockwise. This means that it is only accelerated when the water is approximately at point B with the angle theta. With an excess force. If the Earth continued to rotate about 36 degrees and the water ran from point B to point C, the speed of the water could be accelerated relative to the Earth's rotation to about 24.3 kilometers per hour. So the water is being propelled in a clockwise direction and its speed could theoretically be 24.3 kilometers per hour. However, because the water cannot flow to the right, it is dammed in that direction and low tide occurs on the east coast. After point C the driving force delta G becomes smaller and smaller. And at point B*, the Earth's rotational force is balanced again by the Sun's gravitational field. This means that the water should actually only run back to point B*. But because the accumulated water has a return potential, it will return at point D, roughly between C and B*. Then the water level on the east coast rises again. Because the Sun's gravitational field is almost equally strong on both sides of the Earth, the tides occur in the same way on the other side of the Earth. Meanwhile, the gravitational field of the Moon to the Earth is as follows. With this alone, it can hardly affect the water on Earth. However, the Moon affects the tides in different ways depending on where it is located. For example, if the Moon is in position D, the backflow of water is prevented, which in turn delays and possibly increases the backflow of water. Simply put, the tides are created by the Earth's rotation in the gravitational field of the Sun and Moon. Thank you very much for your attention. See you next time.